Let's work on linear equations together. More specifically, we're going to talk about some independent and dependent variables, as well as filling in some data tables when given a situation and a linear equation. For number one, we have the situation where Miles hits 4 aces per tennis match. Here's our linear equation where we have y is equal to 4 times x. In the linear equation, the x is going to represent the independent variable, and y is going to be representing the dependent variable. Because the number of total aces that Miles hits depends on how many tennis matches he plays, x represents the number of matches played, and y represents the total number of aces hit. Now let's go ahead and fill in our data table together. Here are each of our x values, so these are all just different numbers of matches played by Miles. And our job here is to figure out the value of y in each of these scenarios, or the total number of aces depending on how many matches that he plays. Let's go ahead and use this linear equation here and substitute in 0 in for x to figure out how many aces he hits in 0 matches. So let's write that work down. It's going to be y is equal to 4 times 0, so it's 4 aces per match, but we're playing 0 matches. So 4 times 0, that's just going to be 0. So if he plays 0 matches, he hits 0 aces. Now let's go ahead and use this equation again, but now x is 3, so it's going to be 3 tennis matches. So let's change x to 3 or substitute it in. So we're going to have y is equal to 4 multiplied by 3. This is going to be 3 matches this time. 4 times 3 is 12, so we're going to get y is equal to 12. So in 3 matches, he's going to hit a total of 12 aces. Now let's use this equation again, but x is now 6. Let's take the 6 and substitute it in over here for x. So let's repeat that process. We're going to get y is equal to 4, but this time we're multiplying by 6 because he's playing 6 matches. 4 times 6 is 24, so we're going to get y is equal to 24. So we're saying in 6 matches, he's going to hit a total of 24 aces. In this next scenario, we're going to use this equation, but now x is 9, so it's 9 matches. So let's go ahead and substitute that in. It's going to be y is equal to 4 times, but it's going to be 9 matches this time. So 4 times 9, that's going to be 36. We're going to say y is equal to 36. And one final time we have this equation here, but we're going to substitute this 12 in for x. So go ahead and say that's going to be 12 matches. So it's going to be y is equal to 4 multiplied by 12 matches this time. So 4 times 12, that's going to be 48. So we're going to say y is equal to 48. So looking at this table, that means in 12 matches, he's going to hit a total of 48 aces. Here's number 2. In this problem, Lisa has already eaten 3 chocolates and she's going to continue to eat 5 more chocolates per hour. Here we have our linear equation, which is y is equal to 5x plus 3. Our independent variable here is going to be x, while our dependent variable here is going to be y. X would represent our number of hours, that's going to be the independent variable, and y is going to equal the total number of chocolates eaten, or the dependent variable. Let's take each of these values of x, or the number of possible hours that Lisa is going to be eating chocolates for, and solve for each of these missing y values, or the total number of chocolates she had eaten at that point. Let's go ahead and take this linear equation and say that x is going to be 0, so 0 hours go by. Let's substitute that in. So it's going to be y is equal to 5 multiplied by 0 hours, so it's going to be 5 times 0. Then we're going to go ahead and add 3 on afterwards. 5 times 0, that's going to be 0, so she's eating 0 chocolates here, plus the 3 she already ate. 0 plus 3 is going to be 3, so if no more time goes by, she's still going to have 3 that she ate. Then let's go ahead and use the same linear equation, but now x is 2. Let's substitute in 2 in for x into that equation. By doing that, we're going to get y is equal to 5 multiplied by 2 this time. So this is going to be if 2 hours goes by. So we have 5 times 2 plus 3. 5 times 2 is going to be 10, so it's going to be 10 plus 3. And 10 plus 3 is going to equal 13. So if 2 hours go by, then Lisa will have a total of 13 chocolates that she ate. Now, same linear equation, but now x is 4. So if 4 hours go by, let's substitute that 4 in. So we're going to get y is equal to 5 multiplied by that 4. So that's going to be 5 times 4. And we're going to go ahead and add 3 on afterwards. 5 times 4, that's going to be 20. So we have 20 plus 3. And that's going to be a total of 23 chocolates that she ate. Let's go ahead and put that in here. Okay. Next, we have another scenario. So we have our equation here is 6. That's going to be 6 hours. Go ahead and substitute that in. So that's going to be y is equal to 5 multiplied by 6. Let's go ahead and say that's going to be 6 of those hours plus 3. So in 6 hours, she's going to eat a total of 30 plus the 3 that she already ate earlier. 30 plus 3, that's going to be a total of 33 chocolates. So in 6 hours, she'll have eaten a total of 33 chocolates. One more time, we have this linear equation, but now we have 8 hours. Let's go ahead and substitute that in for x. So we're going to have here y is equal to 5, multiply that by 8 hours, so it's 5 times 8. Then we can go ahead and add 3 on afterwards. 5 times 8, that's going to be 40, so y is equal to 40 plus 3. 40 plus 3 is going to be 43. Okay, so in 8 total hours, she'll have eaten a total of 43 chocolates. Here's number 3. In number 3, the temperature was originally 14 degrees Celsius, and then afterwards we noticed that the temperature is going to be dropping 5 degrees colder per hour. Here we have a linear equation, and that's going to be y is equal to negative 5x plus 14. Our independent variable here is going to be x, so we can go ahead and write that down first. And our dependent variable is going to be y, so let's go ahead and write that down as well. Now, as time goes on, we notice that the temperature is going to be dropping, so the temperature is going to depend on how much time goes by or how many hours go by. That being said, x, or our independent variable, represents the number of hours, and y represents the current temperature. Let's go ahead and use this information to fill out this data table together. Here we have x, which just represents all these different amount of hours that go by. And our job is to figure out each of these y values, or what the temperature is going to be at these given hours. Let's go ahead and use this linear equation, and in the first scenario, we have x equals 0, so that means that 0 hours go by. So let's go ahead and substitute that in. We're going to have y is equal to negative 5. Let's multiply that by 0 hours, so it's not going to drop at all, plus 14, the original temperature. Negative 5 times 0, that's going to be 0, it's plus 14. 0 plus 14 is still going to be 14. So at 0 hours going by, the temperature doesn't change, and it's still at 14 degrees. Now let's take the same linear equation, but now 2 hours goes by, so let's go ahead and substitute in 2 in for x here. So that's going to be y is equal to negative 5. That's going to be multiplied by 2 because 2 hours goes by, so it's dropping 5 degrees 2 times, plus 14. So negative 5 times 2, that's going to be negative 10, so we have negative 10 plus 14. Negative 10 plus 14 is the same thing as 14 minus 10, which is equal to 4. So if 2 hours goes by, the temperature is now 4 degrees. Here's our third scenario. Take this equation. Now x is 4, so 4 hours goes by. So let's go ahead and substitute that in. We're going to get y is equal to negative 5. Let's go ahead and multiply that by 4 this time, because 4 hours goes by, plus the original temperature of 14. So negative 5 times 4, that's going to be negative 20. So it's negative 20 plus 14. Negative 20 plus 14, you could just do 20 minus 14, which is 6, but it's going to be a negative 6 because negative 20 has greater absolute value than positive 14. So we have a temperature of negative 6 degrees when 4 hours go by. Now take the same linear equation, but this time x is 6, so 6 hours goes by. So let's take that 6 and substitute it in. We're going to get y is equal to negative 5, but this time we're going to multiply this by 6 because 6 hours goes by, plus the 14 that the temperature was originally. Negative 5 times 6 is going to be negative 30. Negative 30 plus 14, that should just be the same thing as 30 minus 14, which is 16, but it's going to be negative. So we're going to get negative 16 degrees here. One final time for this problem, we have our linear equation, and x is 8, so 8 hours goes by. Let's substitute that in. So we're going to get here that y is equal to negative 5 multiplied by this 8 hours that goes by. Negative 5 times 8. Plus the 14 degrees it was originally. Negative 5 times 8 is going to be negative 40. Negative 40 plus 14. That should be just 40 minus 14, and then make it negative. So that should be negative 26. So at 8 hours, the temperature should be negative 26 degrees, so that's getting colder. Here's number 4. In this problem, Asa originally had $40 in his bank account. Then he's going to continue to add more money in, or deposit $7 per month. The linear equation we're going to have to represent this scenario is y is equal to 7x plus 40, where our independent variable is going to be x here, so let's go ahead and write that down. And our dependent variable here is going to be y, so let's go ahead and write that down as well. Now there's two variables here. We have the number of months that go by, as well as how much money that is going to be in his bank account, right? So we have this 40 and 7, so there's going to be more and more money over time. So the independent variable here is going to be time, or the number of months. And our dependent variable, or y, is going to represent the current balance at that current time. We're given all these different x values, which just represents different amounts of months. So let's go ahead and use that to figure out each of these missing y values, or his current account balance at those given times. So first we'll take this equation here and say x is 0. So if 0 months go by, how much money would be in his bank account? So we're going to get y is equal to 7. Let's go ahead and multiply that by 0 because 0 months are going by. Then we'll go ahead and add 40 here. 7 times 0, that's going to be 0. So it's going to be 0 plus 40. 0 plus 40, that's going to be 40. So if no time goes by, Asa is going to have $40 in his account. Now let's take this linear equation again. Now x is going to be 3. Let's go ahead and substitute 3 in here. So that's going to be y is equal to 7 multiplied by 3. This time 3 months are going by. So go ahead and add the $40 he had to begin with here. So that's going to be 7 times 3, that's 21. So 21 plus the 40 he already had, that's going to be a total of $61. So in 3 months, Asa will have $61 in this bank account. Then we take this linear equation, x is now 6, so 6 months goes by. Let's go ahead and substitute 6 in here. So we're going to get y is equal to 7 multiplied by 6. And then we're going to go ahead and add the 40 he already had. 7 times 6 means he gains $42 in that 6-month time period, plus the 40 he already had. That's going to be a total of $82. Okay, so in 6 months, Asa should have 82 bucks in total. Next scenario here, we see our linear equation, say x is 9. So if 9 months goes by, let's see how much money would be in this account. We're going to have y is equal to 7. We're going to multiply that by 9. So 7 times 9. Let's go ahead and add 40 on afterwards. So 7 times 9, that's going to be 63. 63 plus 40, that's going to be a total of $103. So it's going to be $103 is his account balance at that point. One final time, let's take this linear equation, but now x is 12, so 12 months go by, or a full year. Let's go ahead and substitute that in. So that's going to be y is equal to 7. Let's go ahead and multiply that by 12. So that's going to be 12 months. So 7 times 12 plus 40. 7 times 12, that's going to be 84. 84 more dollars plus the 40 he already had. That should be a total of $124. So let's go ahead and put 1, 2, 4. So in a year, he should have $124 if he doesn't take any money out and he just deposits that $7 per month. Here's number 5. For number 5, Marshall originally had 50 levels of a video game that he wanted to play, and he's going to beat 2.5 levels or 2.5 levels per day. Here we have our linear equation. It's going to be y is equal to negative 2.5x plus 50, whereas independent variable is going to be x as usual, while the dependent variable here is going to be y as usual. So for the independent variable, again, we have that going to be x here, and x is going to represent time, or the number of days that go by, and the dependent variable is going to be y, which represents the number of levels left that he needs to beat. Let's go ahead and fill in this data table together. Let's take all these x values here that we are given. These x values tell us how many days go by. And let's go ahead and find out each of these y values, which is just how many levels he has left to beat on these given number of days after they've gone by. Let's go ahead and take this equation here, and let's take x equals 0 and substitute it in here. So if 0 days go by, we're going to have y is equal to negative 2.5 multiplied by 0 days. So he's not going to play the video game at all, plus the 50 levels he still has to beat. So negative 2.5 times 0 means he's not going to beat any levels, plus the 50 he still has to beat. So 0 plus 50 is 50. So on day 0, he still has 50 levels to beat because he hasn't started playing yet. What about for this next scenario? So we have x equals 5, so 5 days go by. So let's go ahead and substitute that in. So that's going to be y is equal to negative 2.5. We're going to multiply that by 5. So if 5 days goes by, he's definitely going to beat some levels. So plus the 50 original levels. So what's negative 2.5 times 5? Well, if you need to do that on the side, feel free to do so, but that's going to be negative 12.5. So in 5 days, he's going to beat 12.5 levels. That's what the negative means. And if we take that away from the 50 that he originally has to beat, then 50 minus 12.5 is going to be positive 37.5. So after 5 days, yes, he's going to beat 12.5 levels, but we're going to say that he still has 37.5 levels to beat here. Next, let's take this equation here and say x is going to be 10. So let's go ahead and substitute that into the equation. So if 10 days go by, so y is equal to negative 2.5. Multiply that by 10 days going by. So multiply by 10. Let's go ahead and add 50. So negative 2.5 times 10, that's going to be negative 25. So that means he beats 25 levels. So how many levels does he have left? Well, negative 25 plus 50 is positive 25. So after 10 days go by, Marshall still has 25 levels left to beat. Next, let's take this equation here, and x is 15, so 15 days go by. Let's substitute that in. So we're going to get y is equal to negative 2.5. Let's go ahead and multiply that by 15 days going by, and then add the 50 levels that he started with. So negative 2.5 times 15 is going to be negative 37.5, plus the 50 that he started with. And if you do 50 minus the 37.5 levels he beat, he should still have 12.5 levels left. So let's go ahead and say that after 15 days, Marshall still has 12.5 levels to beat in his game. Okay. One final scenario, let's take this equation here, but this time x is going to be 20. So if 20 days go by, what's going to be happening here? So let's go ahead and substitute that in. So I'm going to actually do it over here under the table. So we're going to get y is equal to negative 2.5, multiply that by 20 days. Let's go ahead and do 20 here, and then plus the 50 that he originally has to beat. Negative 2.5 times 20 is going to be negative 50. Negative 50 plus 50 is going to be 0. So y would be 0. So if 20 days go by, Marshall is going to have 0 levels left to beat here. Here's one final problem. Let's check out number 6. In this problem, Ava was 14.5 feet underwater to begin with. Then what happens? It looks like she's going to start swimming towards the surface 1.25 feet every single second. Okay, so she's making her way towards the surface, and she's getting shallower and shallower towards the surface of the water. Here we have our linear equation, which is going to be y is equal to 5/4 x minus 14.5, and this 5/4 is equivalent to this 1 and 1/4, just different versions of the same thing. Our independent variable here is going to be x. Let's just go ahead and write that in real quick. And our dependent variable here is going to be y as usual. So we go ahead and write that in as well. Now we have two variables here. One is dealing with time, the number of seconds that go by. The other one is dealing with Ava's location, what her elevation is measured in feet here. So for our independent variable, x is going to represent the time or the number of seconds, and y, or our dependent variable, is representing Ava's current location. Let's go ahead and fill in this data table together now. Let's take all these given x values of 0, 1, 2, 3, and 4, and these are just telling us how many seconds have gone by. And let's go ahead and use that information to figure out all these missing y values, or figuring out Ava's current location at these different times. Let's go ahead and take this linear equation and say that x is going to be 0 first. So if 0 seconds go by, we're going to go ahead and write y is equal to 5/4. Let's go ahead and multiply that by 0, so times 0. And then we're going to subtract 14.5. So let's go ahead and minus that. And so we're going to have 5/4 times 0. That's still going to be 0. 0 minus 14.5. 0 minus 14.5 is just going to be negative 14.5. So that's going to be the location of Ava if no time goes on. So she's going to stay put right where she began with. Now for this linear equation here, let's go ahead and use it again, but now x is 1, so only 1 second is going to go by. Let's go ahead and take that 1 and substitute that in. So we're going to have y is equal to 5/4. Let's go ahead and multiply that by 1, because 1 second is going by. And then I'm going to write minus, but instead of 14.5, I'm going to write 14 2/4, just so we have common denominators, okay? Now 1 times 5/4, that's going to be 5/4. So I'm going to leave that alone as 5/4. And then we're going to go ahead and take away this 14 2/4, but I'm just going to write this as an improper fraction. So 14 times 4 is going to be 56. 56 plus 2 is going to be 58, so it's going to be minus 58 over 4. And so 5 minus 58 over 4, because they have common denominators, is going to be negative 53 over 4, which is going to also turn into negative 13 1/4. So feel free to pause to think about that, or do the long division, but you can also hopefully trust that that's what it's going to be. So after 1 second, Ava's location is a little bit higher up, closer to the surface at negative 13 1/4 feet. Now let's go ahead and take the same equation, but now x is going to be 2, so 2 seconds goes by. Let's go ahead and substitute that in. So we're going to get y is equal to 5/4. Let's go ahead and multiply that by 2 here, right? Because 2 seconds are going to go by. So let's multiply this by 2 over 1. And then let's go ahead and take away this 14 1/2. Okay. Now if we're multiplying here, we can cross cancel. So we're going to notice here that this 2 and this 4 is going to become a 1 and a 2. So if we do that, we're going to get y is equal to 5 over 2 minus 14.5. Now, 14.5 as an improper fraction, 14 times 2 is 28, plus 1 is 29. So it's going to be minus 29 over 2. So we now have common denominators. So what is 5 minus 29? That should be negative 24 over 2. negative 24 over 2 is going to be negative 12. So at 2 seconds, this location for Ava should be at negative 12 feet or 12 feet underwater. Now let's go ahead and take the same equation, but now x is going to equal 3. So let's substitute in 3 in for x. So we're going to get y is equal to 5/4. We're going to multiply this by 3 here. Okay, and then we're going to subtract 14 and 1/2. Okay, so this 5/4 times 3, that's going to be 5/4 times 3 over 1. That's going to be 15 over 4 minus, and we already know this 14.5 in terms of fourths is going to be this 58 over 4. So minus 58 over 4. And so 15 minus 48 is the same thing as 58 minus 15. So that's going to be 43, but it's going to be y is equal to negative 43 over 4, which is going to simplify down to being, as a mixed number at least, negative 10 3/4. So Ava is getting closer to the surface, but she's still 10 3/4 feet below the surface. Okay. One final scenario, take the same equation, but now x is 4, so 4 seconds go by. Let's go ahead and substitute that in. So we're going to say y is equal to 5/4. Let's go ahead and multiply that by 4, so that's going to cross cancel nicely. And then take away this 14 and 1/2 afterwards. Okay, so multiplying this 5/4 times 4, the 4's are going to cross cancel, so we're going to get y is just equal to 5 minus 14.5. So what's 5 minus 14.5? Well, it's the same thing as 14.5 minus 5, just make it negative. And so that's going to be negative 9 and 1/2. So at 4 seconds, Ava is the closest to the surface out of all the given times here, but she's still 9.5 feet underwater. Alrighty, so there you have 6 different practice problems on dealing with some linear equations, identifying the independent and dependent variables for each scenario, and then going ahead and filling in a data table by using some substitution, some order of operations, and just evaluating them and filling in our data table. So hopefully you found the video helpful. If you did, please consider giving it a thumbs up. And as always, keep up the great work, and I'll see you in the next one.